Good afternoon to everyone. Okay, so I think you can hear my voice now. So in the last class, just I gave the rule number 3 and rule number 4. Okay, can you hear my voice properly?
Yes, sir.
Okay, thank you.
Yes, sir.
Okay, thank you. If in a differential equation mdx plus the mdy equal to 0, okay, dou m by dou y minus dou n by dou x divided by n is equal to function of x alone, then e power integral f of x dx is an integrating factor. Okay, so the first problem in rule 3, solve x square plus y square plus 2x into dx plus 2y dy equal to 0. Okay, now, so first you should check it whether this is exact or not. So this is m. This is m. So dou m by dou x is equal to, sorry, dou m by dou y. Differentiate m partially with respect to y. You get 2y. Similarly, dou n by dou x equal to, or you get 0. Okay, you get 0. This is a function of y. So, and hence dou m by, and hence this is not equal, and hence the given equation is not exact. Not exact. And you should check it whether this is comes under rule 1 or rule 2. Okay, so it's not comes under rule 1 and rule 2. So then it is better to check this ratio. Okay, if this ratio is a function of x, then it is comes under rule 3. Otherwise, otherwise rule 4. Otherwise, we need to use rule 4. Okay, now here dou m by dou y minus dou n by dou x divided by n. This is a 2y minus 0. N is 2y. This is equal to 1. I can't write this is x power 0. So it's a function of x alone. Function of x alone. So then the integrating factor is e power integral f of x dx. Therefore, integrating factor is e power integral f of x. F of x is 1 dx. So this is e power x. So now I'm going to multiply e power x throughout this equation 1. Multiply. So equation 1 into e power x implies, so please verify it carefully, x square into e power x plus y square into e power x plus 2x into e power x into dx plus 2y e power x into dy equal to 0. So this is equation number 2. Okay, now this is m. Okay, this is m. This is m. So dou m by dou y equal to this is x. Okay, I think dou m by, only here function of y. This is 0. This is the first and third is 0. Here you have function of y. So 2y into e power x. And dou n by dou x. is 2y into e power x. So you can see that here m dou m by dou y is equal to dou m by dou x. So this implies equation 2 is exact. We need to find the solution of equation 2. Solution of equation 2 is integral m dx over y is constant, or the integral y is constant, and the integral the terms of m not containing x, terms of m not containing x into dy equal to c. So here m is here, this is m. Okay, so I will write here. So integral y, treat y as a constant, x square into e power x plus y square into e power x plus 2x into e power x into dx. Terms of m not containing x, nothing. So that is just a 0, or you can leave it. It is equal to c. Is equal to c. Now should integrate with respect to x. So only here you have what? Integration x square e power dx. You can split into 3 integrals. Y equal to c, x square into e power x dx plus y square is constant. So y square into integral e power x dx plus 2 into integral x into e power x dx equal to c. I call this is equation number 3. So this is equation 3. So the second integral you can easily get it. Even third integral you can get it. The only thing is the first integral. So you can use by parts, but now I am going to use Bernoulli's formula for integration. Okay, Bernoulli's formula for integration is integral uv dx is equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus u 4 dash v5 and so on minus. So here u dash means the derivative of u double dash means the derivative of u dash, and so on. Here v1 is if you integrate v, you get v1. If you integrate v1, you get v2. Similarly, so choosing u and v, you know the procedure for you can use ILATE. Okay, inverse function, logarithmic, algebraic, trigonometry, exponential functions. So in this order, from left to right. Okay, here the first function is what? X square into e power x square into e power x dx. So here x square equal to u and v equal to e power x. So x square, keep x square as it is, u. This is u, this is v, and if you integrate v e power x minus, if you differentiate x square, get 2x v2. If you should integrate v1, so e power x minus, sorry, plus. You should differentiate 2x, I will get 2, and if you integrate e power x, you get e power x. So that's all. Similarly for x into e power x dx. So keep x, integrate e power x. Differentiate x, you get 1, you should integrate e power x. So x into e power x minus e power x. Okay, now I'm going to use these results in equation 2. Equation 2 implies the left hand side is the first integral, second integral, third integral. First and third, I am going to use this result. Okay, first integral, I am going to use x square e power x minus 2x e power x plus 2 into e power x. This is for the first integral. And the second integral is I need to integrate e power x dx. So y square into e power x. Y square into e power x. Third integral here I have. So x into e power x minus e power x. Is anything is cancelling? What I done the mistake? Yeah.
Sir, without highlight the previous step, it's in the form of e power x into f of x plus f dash of x. So that's e power x into f of x, right?
Sorry, I can't. Please repeat.
Sir, in the third equation.
Third equation, yeah.
The first part and the last 2 into.
The first part is x square into e power x.
Yes, sir. X square into e power x plus e power x into 2x.
E power x into 2x.
So that's third, 2 into integration of x into e power x.
Yeah, yes,
that
yes.
one.
Yes.
That's nothing but e power x into x square, no, sir, when integrated.
Of e power x into x square.
Yes, sir.
Final answer. You are getting. You are telling the final answer.
No. Final answer is x square plus y square into e to the power x is equals to c.
Yes, correct. Final answer is correct.
Sir,
but
there is a,
but
there
I
is
don't. Yeah, but I don't. I don't understand still your question.
So when integrating it by parts, integral of x square to the into e power x, we'll get it as x square e power x minus 2 times of integral of x e power x. So that and the third one, third integral will be cancelled.
No, okay. Yeah, but okay. Suppose if I give here x power 6 here, then how you will do it? How many times you will do by parts? Okay, so if the function is bigger, by parts is very difficult. Okay, so that is the reason I am explaining here Bernoulli's. So the function is bigger, so you can easily done. Even if it is x power 6, you can do it in a single line. I will do it here, x power 6. Can I do it, or you can try? But I missed only here 2. If I missed 2, you can check it here. Here I wrote 2 here, but here I missed 2. Okay, so these 2 gets cancelled. These 2 gets cancelled. So final answer also x square e power x plus y square e power x equal to c. X square plus y square into e power x is equal to c. Okay, I got it. What you are telling. So when you are evaluating this term, this interval is cancelled. I think what I am saying is correct. I think Vignesha Pragadish. I don't know. Pragadish.
Sir, actually there is a rule e power x into f of x plus f dash of x.
Yes, yes,
When
yes.
we integrate it, we will get e power x into f of x. No, sir?
Yes, yes, yeah.
It's in the form of the same.
Yeah, 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 understand.
So we'll get
Okay.
directly.
Yeah, okay. So you should, if you use Bernoulli's, then you can easily simplify, you can easily get the answer. Okay, I will tell you. Suppose if we have integral x power 6 e power x dx. So you will try to get the answer, okay, by parts. So I think you can verify later by parts whether this is the correct answer. So just you should write x power 6 and e power x, differentiate this, integrate this. Again, differentiate this, integrate this. Okay. So even for some other function, even for x cube into sin x, x cube into cos x. Okay. So this formula is very helpful when you have the algebraic power is more. Just to have x dx, x square dx, you can do it by parts. Okay. Okay, thank you for your question and explanation. So without discussion, the class is boring. Okay, sometimes I don't understand what you are telling, so please tell little bit slowly. Okay. Okay.
Sir,
Yeah, please tell. Karthikeyan,
sir, could you show the previous slide for a moment, sir? I'd like to take a screen.
previous slide. Okay.
Thank you, sir.
Okay. So the final answer is x square plus y square into e power x equal to c. Okay. Now the next problem. Xy square minus e power 1 by x cube into dx minus x square y into dy equal to 0. So this is m. Okay, this is m, including minus sign. This is m. So you can try this problem, but just I will tell you, this is not exact. You can check it. Dou m by dou y. Dou m by dou y is equal to 2xy, and then dou n by dou x equal to, if you minus 2xy. So this is not exact. It's not equal and hence not exact. Okay. Now I think we are discussing rule 3. Yeah. So this is not homogeneous. This is not comes under rule 2. So and hence I'm going to calculate the ratio. What is the ratio? Dou m by dou y minus dou m by dou x divided by n is equal to 2xy minus into minus plus 2xy by n. What is n? Minus x square y. So if you simplify, you'll get 4xy divided by minus x square y. Okay, 4 minus 4 by x. Minus 4 by x. This is a function of x. Function of x alone. So and hence integrating factor is equal to e power integral f of x into dx. This is equal to e power integral f of x is minus 4 by x into dx. So which is equal to e power minus 4 integration dx by x is log x. So e power log x power minus 4. This is 1 by x power 4. So you need to multiply by 1 by x power 4, equation 1. So I leave it to you. So I'll tell the final answer, note down the final answer and check it, cross check it. Answer is minus y square by 2x square plus 1 by 3 into e power 1 by x cube equal to c. Okay. So next, rule 4. Rule 4. If in the differential equation mdx plus ndy equal to 0, then here you need to calculate dou n by dou x minus dou m by dou y. The previous one, what is the difference between previous one and this? The previous one, here dou m by dou y minus here dou n by dou x. So just interchange the place, okay? And the denominator n. In the previous case, here we have m. And in the previous case, it is a function of x. Here it is a function of y alone. Then the integrating factor is e power integral f of y into dy is an integrating factor. Okay. Now this is the problem. Okay. So please check it whether this is exact or not. So this is m. And this is n. Okay. Now dou m by dou y. Okay, dou m by dou y is what? 2y. Sorry. Rule 4. Rule 4. Y power 4. This is not y square. Y power 4. Y power 4 plus 2y xy cube plus 2y power 4 minus 4x into d. So and hence this is 3 y power 4 is what? If you are partially differentiating with respect to y, so 4 y cube plus 2 and dou n by dou x is equal to y cube minus 4. So this implies dou m by dou y is not equal to dou n by dou x. This implies the given equation 1 is not exact. Equation 1 is not exact. So we need to convert into exact. So type 1. Please check it whether this is homogeneous. It is not homogeneous. And then you should check it. It is comes under rule 2. Okay, rule 2. And rule 3 and rule 4 you need to check simultaneously. If it is not comes under rule 3, so it should be comes under rule 4. Okay, so now here you need to calculate what? Dou n by dou x minus dou m by dou y divided by m. Okay, what is dou n by dou x? Y cube minus 4 y cube minus 4. What is dou m by dou x? 4y cube plus 2. So minus is common. So what is the denominator? M. M is y power 4 plus 2y. So this is equal to minus 3y cube minus 6. So take y is common. Y cube plus 2. The numerator should take common minus 3. So y cube plus 2. So y into y cube plus 2. So after cancelling, we'll get minus 3y. This is a function of y alone. This is a function of y alone. Okay. So now you need to multiply. Equation 1 into minus 3 by y. So implies you should need to multiply by minus 3 by y. Okay, but still need to find the integrating factor. So I got only minus 3 by y. The integrating factor is equal to e power integral f of y dy, that is minus 3 by y dy. So e power minus 3 integration dy by y is log y. This is equal to e power log y power minus 3. So y power minus 3 or 1 by y cube. So now equation 1 into 1 by y power 3. So now please check it. Y power 4. So I'm going to multiply this equation by 1 by y cube. Y power 4 divided by y cube plus 2y divided by y cube into dx plus xy cube divided by y cube plus 2y power 4 by y cube minus 4x divided by y cube into dy equal to 0. So if you simplify, you will get y plus 2 by y square into dx plus x plus 2y minus 4x by y cube into dy equal to 0. So this is equation 2. Now this is your m, this is your n. So check it, dou m by dou y equal to 1 minus 4 by y cube. To differentiate with respect to y. So dou n by dou x is equal to 1. This is 0 minus 4 by y cube. So you can see here these two are equal. So and hence equation 2 is exact. Equation 2 is exact. Okay. Now if it is exact, then we can find the solution of equation 2. Solution of equation 2 is integral m dx, keep y is constant, and plus integration terms of n not containing x. Not containing x is only 2y. So this is everything is constant. I treat everything is constant. So integration of dx is x plus 2 y square by 2. So 2 gets cancelled. Equal to c. So the final answer is y plus 2 by y square into x plus y square equal to c. So this is the final answer. So before going to the next section, I will give some other problems in maximum minima. Okay, so just I will give the problem. You'll try. Still, you have time. Okay. I think syllabus is over for first CA. So find the maximum and minimum value. Minimum values of f of x comma y equal to 4x square plus 9y square minus 8x minus 12y plus 4 over the rectangle is the first quadrant. Bounded by the lines x is equal to 2, y equal to 3, and the coordinate axis. The coordinate axis solution. This is x. So x is equal to 2. Since y equal to 3. So 2 comma 3. 2 comma 0. And 0 comma 3. And 0 comma 0. So now, as usual, you should find O. This is A. This is B. This is C. So find the fx. Fx is 8x and minus 8. Fy is what? 18y minus 12. Find all the 5 partial derivatives. Fxx is 8, fxy is 0, fyy 18. Okay. Now, if we equate fx is equal to 0 and fy equal to 0, so I get 8x minus 8x is equal to 8. 8x is equal to 8. This implies x is equal to 1. Okay, and fy equal to 0. That is 18y equal to 12 implies y equal to 2 by 3. So the critical point is 1 comma 2 by 3. So that is inside the rectangle. Inside the rectangle. Critical point or stationary point 1 comma 2 by 3. Okay. So now at 1 comma 2 by 3, A is 8 because A, B, C are independent of X and Y. So C is 18. So delta is AC minus B square. AC minus B square, that is 18 into 8. 18 into 8 is 144 minus 0. 144, which is greater than 0. So delta greater than 0 and A greater than 0. So this implies point 1 comma 2 by 3 is minimum point. Minimum point. And the minimum value, please calculate and tell the minimum value.
-4, sir.
-4 of f of okay, correct, yes, thank you. That is equal to -4. Okay, so now next you should investigate not only the endpoints and also along this line, along this line, along this line, along this line. You should find, for example, I will tell you along OA. Along OA, Y equal to 0. Along OA, Y equal to 0. Substitute Y equal to 0 here. So the given function. So then f of x comma 0 equal to 4x square minus 8x plus 4. I will take this is a capital F of x. Capital F of x. It's a function of single variable. So find the f dash of x, capital F dash of x, that is equal to 8x minus 8 and equal to 0. So this implies I got x is equal to 1. X is equal to 1. And also find the second derivative. Second derivative is 8, which is greater than 0. So therefore, x is equal to 1 is 1 will give the minimum minimum value for this function. But we assumed already y is 0. Y is 0. Okay. So f of 1 comma 0. F of 1 comma 0. First you tell 1 comma 0 is a minimum point. 1 comma 0 is minimum point and minimum value is either you can substitute 1 comma 0 in the original function or substitute x is equal to 1 in this function. You will get what? 1 8 0 0. So minimum value is 0. Okay, now after investigating through the line, and now you find the corner point 0 comma 0 2 comma 0. Okay, now f of 0 comma 0 is 0 and then f of 1 comma 0. So f of 1 comma 0 2 comma 0 2 comma 0. So f of 2 comma 0 is, please tell what is f of 2 comma 0? 4 16 16 minus 16 0 plus 4. I think 4. Check it. So now similarly along other boundaries, for example along this boundary AB. In AB x is equal to 2. Along AB. So here x is equal to 2. So now f of 2 comma y. F of 2 comma y is what? Please check it. 16 plus 9y square minus 16 minus 12y plus 4. So I got 9y square minus 12y plus 4. I will consider this is some function g of y. Then you got this function 9y square minus 12y plus 4. What is your answer? Okay, please check it. Now, g dash of y equal to 0. G dash of y equal to 0 implies 18y minus 12 equal to 0. So y equal to 2 by 3. Second derivative, g double dash of y equal to 18. 18 is what? Which is greater than 0. So this implies y equal to 2 by 3 is a minimum point for this function. Y equal to 2 by 3 is a minimum point for this function. So y equal to 2 by 3 is minimum point for the function g of y. Okay. So, but you are assuming x is equal to 2. So, therefore, 2 comma 2 by 3 is minimum point of f of x comma y. This is minimum point of g of y. So, minimum value f of 2 comma 2 by 3 is equal to, so anyone do it and tell the answer f of 2 comma 2 by 3.
Same zeros.
0. Okay. Manikantana. Okay. So 2 comma 2 by 3 is 0. Okay, now at the corner. Corner means 2 by 3. So please tell f of 2 comma 3. Please tell f of 2 comma 3. Similarly, somebody try at along BC. Somebody will try along CO. So we can quickly finish the problem. So I need f of 2 comma 3.
49, sir.
49. Okay, thank you. 49. Okay. So now along y equal to 3, not y equal to 3, on the line, what is the line? That is a BC, along BC. Here y equal to 3. Okay, now f of x comma y is 3 equal to 4x square minus 8x plus 49. So please check it whether it is correct or if it is not correct, please tell quickly. Okay, so I will take this is h of x. H of x. So h dash of x is equal to 8x minus 8 and equal to 0. Equal to 0. So function of single variable h of x. This implies x is equal to 1. H double dash of x equal to 8, which is greater than 0. So therefore, x is equal to 1 is also a minimum point. Is minimum point of h of x. So, and hence 1 comma 3 is minimum point of the given function f of x comma y on the line, okay, on the line BC. Okay. Now, minimum value. Minimum value is f of 1 comma 3 equal to f of 1 comma 3. Calculate and tell.
45, sir.
Yes, 45. Correct. Thank you. And at the corner, at the corner point 0 comma 3. Okay. At the point C. Okay. At the point C. F of 0 comma 3 equal to so somebody do it and tell.
49.
Yes, correct. 49. Okay, thank you. And then finally, along CO. CO. Here x is equal to 0. So f of 0 comma y equal to 9y square minus 12y plus 4, which I will take some I of y. So I think you can check it. For this is same as for x is equal to 2. The same function. 9y square minus 12y plus 4. You can check it here along AB. Okay. So you'll get the same result. Okay, which is the same case as for x is equal to 2. So there is no need to do it again. Okay. So therefore, the absolute minimum value is what is absolute minimum value? You can check it here. In this case, here how minimum value is 49, 45, 49, and here 0 for x equal to 2, 0. Similarly, for x is equal to 0, x equal to 0 also 2. The last case also 0. So here minimum value is what? Minimum value is 0 here 0, here 4. So at the critical point I have what? Minimum value, so minus 4. So out of this, minus 4 is the minimum. So the point is 1 comma 2 by 3. And also find the maximum value. First, now I am going to write the minimum point and the minimum value. Okay. The absolute minimum value is minus 4, which occurs at 1 comma 2 by 3, and the absolute maximum value is, so please tell what is the absolute maximum value? Anyone? Yeah, 49. And also you should tell the points.
At 2 comma 3 and 0 comma 3.
Yes, which occurs at 2, 3 and 0, 3.
0,
Yeah.
3.
Okay, thank you. So I think now time is okay. I will give the problem a try. So try as a practice problem. So find the maximum and minimum value of the function f of x comma y equal to 3x square plus y square minus x over the region or the region 2x square plus y square less than or equal to 1. So as usual, you should find fx, fy, all the 5 partial derivatives and find the critical point and check it whether the critical point is a maximum or minimum point. And then from this on the boundary, okay, on the boundary, you need to check it. So I'll take y square is equal to 1 minus 2x square. Okay, y square equal to 1 minus 2x square. Now I'm going to substitute this y square equal to 1 minus 2x square here and convert into function of x. Convert into function of x, single variable. Okay, single variable. So after getting function of x, what you will get? Please tell.
Critical points.
Please tell. Capital F of x equal to so 3x square plus 1 minus 2x square minus x. So x square minus x plus 1. X square minus x plus 1. So now capital F dash of x, find the first derivative, 2x minus 1 and equal to 0. So x is equal to what? 1 by 2. So second derivative is 2, which is greater than 0. So and hence x is equal to 1 by 2 is minimum point. And x equal to 1 by 2 is minimum point. But we need to find the corresponding y value. So x is equal to 1 by 2 is minimum point of f of x. But we need to find the corresponding y value. So we know that y square equal to 1 minus 2x square. From this we can find the value of y. So at x is equal to 1 by 2, y square equal to 1 minus 2x square. So y square equal to what? 1 minus 2x is what? 1 by 2. So 1 by 4, which is equal to 1 minus 1 by 2, which is equal to 1 by 2. So y square equal to 1 by 2 implies y equal to plus or minus 1 by root 2. So the minimum point is the minimum point is 1 by 2, x is 1 by 2, y is plus 1 by root 2, and x is 1 by 2, y is minus 1 by root 2. So you should find the minimum value at these 2 points. So I leave it to you. Minimum value, okay, it is f of 1 by 2 comma 1 by root 2. So find out, and minimum value f of 1 by 2 minus 1 by root. Okay. So, and then next you should find at the corner point. At the corner point, you need to find okay the value of f of x comma y. What is the corner point? Actually, here, this is the region. 2x square plus y square less than or equal to 1 is the region. So the corner point of this region, I'm going to substitute x is equal to 0. When x is equal to 0, what is y? Y
Plus
equal
or minus
to,
1.
yeah, plus or minus 1. When x is equal to 0, y is plus or minus 1. Similarly, when y equal to 0, x is equal to 2x square equal to 1. So x square equal to 1 by 2, x is equal to plus or minus 1 by root 2. So at the corners, there are 4 corners. So one is when x is equal to 0, we have y equal to plus or minus 1, and when y equal to 0, we have x is equal to plus or minus 1 by root 2. So there are 4 corners. So 0 comma 1 and 0 comma minus 1 and 1 by root 2 comma 0 and minus 1 by root 2 comma 0. So your work is you should find f value at each of the point. F value at each of the point. Okay, and then I'll give the final answer. The given function has the absolute minimum. Absolute minimum value is minus 1 by 12 at the point 1 by 6 comma 0. I think this is a stationary point. This is a stationary point. And absolute maximum. Absolute maximum is 3 plus root 2 by 2 at minus 1 by root 2, this point, minus 1 by root 2 comma 0. Okay. Now, next column, I'm going to give the idea. I think this column, Karthikeyan sent this column to me. Okay. Find the envelope of the circles. Find the envelope of the circles whose diameters are double ordinates of a parabola. Okay, so I need to draw a circle and a parabola, but I don't know how to draw here. Okay, first I will draw the parabola. Okay, this is the center. Okay, this is, I'll take h comma k, h comma 0. So this is the diameter of the circle passing through the origin. Okay, now this is the parabola y square equal to 4ax. Okay, now here x is h, x is h, so and hence y square equal to 4ah, 4ah. So y equal to 2 into root of ah. So this point is h comma 2 into root ah, and this point is h comma minus 2 into root ah. So the diameter of the circle is 4 into root of ah. That is twice the ordinate of the, that is a twice ordinate, and that is given the question. Find the envelope of circle whose diameter is double the ordinates of the parabola. Okay, now I'm going to write the equation of the circle. The equation of the circle is here x minus h whole square centered at h comma 0 plus y square equal to radius. Radius is 2 root ah, 2 root ah whole square. Now, if you simplify this, you'll get x minus h whole square plus y square equal to 4ah. So please check it. Differentiate equation 1. Equation 1 with respect to h, we get minus 2 into x minus h. This is 0. This is 4a. So x minus h is equal to minus 2a. H is equal to x plus 2a. So this is 2. Substitute h is equal to x plus 2a in 1. So if you substitute, 1 implies x minus x plus 2a whole square plus y square equal to 4a into h. H is x plus 2a. So x gets cancelled. 2a whole square is 4a square plus y square equal to 4ax plus 8a square. So what is y square from this? Y square equal to 4ax plus 4a square. So y square equal to 4a into x minus x plus a. So this is the final answer for the problem. So I think I finished enough number of problems. So remaining, you need to do it little bit more. Okay. And if you have any doubts, you can ask to me. If you have any doubts, and now I am sending one more problem in the group. Okay, that is already I sent this problem to you. I think some of you solved and sent to me. Okay, if you see your WhatsApp, you can see the problem. So actually this problem is very similar to this problem, the first problem. So you can see your WhatsApp also. Okay, the function f of x comma y is 48x plus 96y minus x square minus 2xy minus 9y square, and the x value is in the problem the range of x value is 0 to 50, and the range of y value is 0 to 25. So you'll get a triangle, sorry, you'll get a rectangle like this. Okay, so you can solve this problem. Just now I sent through WhatsApp in the group using this method, and then you can if you have any doubt, you can ask me. Otherwise, you can post the answer. Okay, thank you. If you have any doubts, you can ask me. Otherwise, we will meet next Monday. Okay, thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.